Well, it's great to see so many of you here, and you're all interested in hearing about what we're going to talk about today. My name's David Worthington. I'm a freelance NAV consultant. I've been working in the NAVT in Velbeck for the last 7 years, and been before that a developer for almost 20 years. My interest in the last few years has been working in performance testing and optimization in NAV. So that's some of the work that I've been doing there at the NAV team is what we're presenting today. And Dmytro?
Okay. Hello, everyone. My name is Dmytro Sitnik. I work at Microsoft in Denmark, and I worked there for last 8 years. And all the time I worked as software development engineer in different platform teams of NAV product. So I worked with Seaside, ODBC, reporting, query, data stack, permission licensing, and a bit with Office 365 integration.
So what are we going to talk about today? Monitoring and diagnosing Microsoft Dynamics performance. So we, like I said, want to show you some of the things we've worked on in the NAV team in the last 2 releases. Performance counters, that was something we added in NAV 2013 for the NAV server. Event tracing was added in 2013 R2. And some of you might know we released an application profiler on Codeplex. Well, do any of you know that we released an application profiler on Codeplex? Oh, too many, because I was going to give the first person that, and it was, I did miss the front row. So there was a t-shirt, thanks. Yeah, so that's great to see. People have actually looked at it, and if you like, this is a sort of replacement for the old client monitor that people knew and loved. So what are we going to cover today? A bit of a brief introduction to what we think monitoring and diagnostics is about, an overview of the NAV architecture and how this performance monitoring, what things you might be interested in monitoring in the NAV architecture, a look at what the performance counters are, and then a quick look at how you can monitor those performance counters with a new tool called Application Insights. And then we'll look at the application profiler and how that works. We'll have a look at what these ETW events underneath the hood, what they're about and how they work and how you can also use them in your own applications. And we'll look at what the feature for adding SQL command tracing to NAV, so you can see what SQL commands are being executed, rather what code is associated with the SQL commands. And finally, looking at the SQL dynamic management views. So a lot of stuff to get through. Let's see if we can move through that.
Okay, before we start talking about the performance, let's look at the Navision architecture. Oh, David, we just showed the architecture of the new version, so we need to switch to the current one. Yeah. So this is the current architecture you're all familiar with. And we're sure you all know this, but the reason why we show it because we want to set a focus, and we want to emphasize which type of performance issues we are going to diagnose today. So on this diagram, you can see 3 different clients we have and different servers we have. And then you ask yourself where the perf problem can be. It can be actually anywhere in each of these blocks. So let's start with describing the type of performance issues we can have. Of course, it can be related to network connectivity. So in between of each of these components, we have a network connectivity, and it often network issues which cause the performance problems. If you want to diagnose that, you want to look at the perf counters, which will tell you the latency. So for network, to test how network connectivity is between the SQL server and NAV server, we have a heartbeat performance counter. If you want to test the network connectivity between any other components, you would want to look at any system performance counter. So let's go further and see what other performance problems we can get. So they can be client related. For example, if
They're over there.
oh, sorry. Yes. Okay, so they can be client related. For example, if you have a tablet which is not very powerful, you can get a different type of JavaScript rendering performance issues, and that's why you can get a low performance. Okay, what next? So of course it can be SQL Server related. So I would say from our experience is about 50% of the issues, performance issues, are caused by different type of problems on the SQL Server. Most common one are indexes, like incorrect query plans, or simply the SQL query which is get generated is suboptimal. The other type of problem is can be caused by the NAV server itself. We will talk more about that later. That can relate it to the badly written IO code or any type of platform issues. Yes. So what else can it be? Of course, it can be an issue on the NAV web IIS service. So for example, if we render a huge report and we transfer the data set from NST into the web client and then back to RTC client or the web client, then we can get into performance problems. Okay. So what we're going to talk today is it's only about the server performance and mostly about Navision server performance. Okay. So let's recap which we've talked about. So this is the type of performance issues we can get. It can be a network performance issue, it can be performance issue on the client side, on the SQL server, on the NST. On the NST, it can be caused by the application code or any type of the platform runtime problems. Then we can get performance problem because of the NAV web service, because of the issues in the NAV web service. And each of the blocks we saw on the previous slide, each of the logical blocks we saw on the previous slide, it's a component which can be on a separate either physical or virtual machine. So perf problem can be caused by the high CPU utilization, low memory, or the issues with the hard disk. So let's slowly start getting to narrowing down the and finding the problematic component. And how we can find it is by looking at the perf counters. But what we would better do is look at the perf counters trends. So for example, if you look at the perf counters and how they change within the time, within that time frame you got a perf issue, typically you see one of the perf counters jumps or drops, and that will very well indicate the problematic component. After you have identified the problematic component, you want to more precisely look at what has happened there and what have caused that issue. And to do that, you want to look at the traces. So traces, we at NAV servers is very verbose. It issues a lot of different trace events, and they describe very well what the server does. Okay, so here is, again, the NAV architecture, but on this diagram you can see our architecture of NST only. So on the top we have a first layer contains the client server runtime, then which includes, for example, triggers, on-page triggers, then filtering, evaluation, formatting, then as well, for example, set autocall fields are set by the client runtime on the server side. And in that part, you can get perf problems. So underneath, we have an CL application code, which can execute internal or external .NET components, and that can cause a performance issue. And in the very bottom, we have data access layer. So data access layer consists of two parts, the caching and the SQL layer. So if the code is written in the way that Navision server cannot get the result set from the cache, then it always go to a SQL, and you can get a perf problem because of that. our now NAV application is pretty chatty, and if you have a low latency, then you can get in perf problems. On the NAV-SQL layer, you can get perf issues because the SQL queries which are generated are suboptimal. Okay, that was an introduction to the NAV architecture and potential performance problem we can get, and now we're going to get a bit more into details how exactly they're going to be diagnosed.
Yeah, to start with, just an overview about what we mean by the difference between monitoring and diagnostics. So monitoring is you could just be observing the health of the server. Like you've got some sort of dashboard indicator that's showing you that everything's running fine. And that's what monitoring's about. And hopefully that's, what you can set up with these performance counters and events. You can have, so you find out, that things are running as normal before someone comes and tells you. That's what it's all about. You're trying to preempt that situation. And yeah, you can see trends that allow you to detect potential issues. So hopefully you can see something misbehaving before people start experiencing, end users start experiencing. Diagnostics, that's more for when you've either found a problem or you're looking to improve something and you want to get into details about exactly what's going on. And diagnostics, as we showed, they're very verbose, they're very detailed level event traces. They also contain timing information, and that timing information enables you to do performance analysis. So you can actually get, work out, how long each operation is taking. So an example of the sort of things you could be monitoring is like the average response time is a classic one. So you're looking to see over time how quickly users are getting responses from the server, how long operations are taking on average on the server, and if all of a sudden something crazy starts happening, you pick that up straight away because there's operations taking well over that predefined threshold, and all these events. Wrong button. Yeah. So all these alerts, they can be based on the performance counters telling you something. They could also be based on event log entries appearing. You can set up, monitors on the event log. I think any of you have seen the examples with the SCOM pack for NAV. That's set up to watch for specific event log entries. Or you can look at trace events, and you can be collecting those and monitoring for certain trace events. That's probably more extreme because there's a lot of data to manage there, but it is possible to do that as well. All these things are some indication of the state or an activity in the system that you can be monitoring. So what tools can you use? Well, the one that probably you saw before and it's on every server is the performance monitor. And apart from just looking at that, looking at the performance counters, you can also collect them and create logs over time, as Dmytro was showing, which is interesting for trends. But you can also configure a performance monitor to monitor these thresholds which you've defined and then send you alerts. And that can be done by email or by creating event log entries or some other task. SCOMPAC, which is a much more advanced tool which can do all sorts of rules for monitoring. It can execute tasks itself to sort of interrogate the system. There's unlimited ways you can monitor your system with SCOMPAC. And this new Azure tool, Application Insights, which allows you to collect information from your server if it's running in Azure, but I believe also if it's accessible from the internet, I think is probably the requirement. And there you can create dashboards which show all the performance counters and events you're interested in Azure. It's a very nice and easy way to set up monitoring. Or you can even build your own monitoring tools in NAV because the event tracing and the performance counters are part of the Windows system. There's APIs. You can go in and set up your own code for monitoring these things. So there's a lot of possibilities, a lot of tools that you can use for monitoring. And because we've based the monitoring in NAV on these standard Windows components, it's pretty much compatible with all these tools. So what about diagnostics? So this is the event traces. You've got the NAV event log entries, which probably everyone would be familiar with already. maybe it's a good time to ask a question. Is there any event log entries that you think that we see too much of? Anyone got any complaints? No? Oh, here's a... Okay, that's something like that, yeah. So the NAS messages, yeah, there can be a little bit. Okay, there's a t-shirt for you. Another one of the recent ones, I don't know if anyone's noticed it, if you're using username and password authentication, there's an event there telling you every time someone authenticates, just in case you wanted to know that. It's maybe a little bit too much detail sometimes. The idea is that you can actually filter that stuff, so you can determine what level of detail you want to see in the event log. Now, that's not really possible at the moment, but it is coming, I'm assured, in the very near future to be able to define what they call channels for monitoring different levels and verbosity of events. But in the meantime, you've also got the trace events, which give you all the detail, and you can, in whatever tool you decide to collect them with, you can filter. And these events give you a very low-level temporal view of what's going on in the server. You can see pretty much every action on the server. You can go into SQL and open up the profile. You can see everything that's happening on SQL there, and that's a tool that's obviously used by a lot of people, and I think then probably see that in our next session about SQL performance. And finally, you can get events for other parts of the Windows system, and actually you can collect them together, so you can see, for example, what WCF events are taking place. That's like communication between client and server. And from that you can sort of see, okay, the trace of what then initiated the actions on the server and the corresponding SQL events. So you can actually put it all together in like a correlated trace. So there's lots of possibilities there. So like I said, the event viewer, you can filter on events from NAV. The application profiler tool, which we'll demo, you can see sort of a hierarchical trace of all the application calls and the corresponding SQL. The SQL profiler, you can get all the information about the SQL statements and the execution plans. And then there's a number of different trace event consumers, because the Purview is probably the sort of standard tool, but there's people have built other tools for consuming trace events, and they'll allow you to analyze an event trace. So then comes our next problem, which is, well, we want to demo this, right? But we're only two guys, and how are we going to put a big load on that NAV server? It's it's going to be pretty boring seeing us sort of hit actions really fast. So we took the easy way out, and we decided we'll simulate some load, and we do that in a way of for demonstration here, but it's also how you can benchmark your system by having some well-defined tests that you can run, and then you measure the system, and you do some changes, and you run the test again and see the improvement. It's very hard to do it with real users because they're not so reliable as automated performance tests. And then what's really interesting here, we're just going to show you quickly how it works, but there's a problem in the past has been setting up these large-scale performance tests when you want to say, okay, what is it like when 100 users or 200 users or 500 users hit the system, is that it requires a hell of a lot of hardware to do that. You've got to have a lot of client machines to simulate the load. Luckily, Visual Studio is now offering a service online. So you can take your load test, which you've written in Visual Studio, and then just give it to Visual Studio and say, run this for 100 virtual users, and it'll just spin up user agents in Azure to run those tests for you. It makes it a lot much easier. So now I'm going to try to switch screens here, just briefly. Just to show what it looks like. No? Oh, wrong button. Now I can see it, but I've got to get the mouse over there. Okay, so this is what Visual Studio looks like when it's, I don't know if you can all, you can see it, it's pretty big. So this, oh, that's better. I'll have to look back this way. So I don't know how many of you are familiar with Visual Studio Load Test or ever used it. What I've defined here is a bunch of scenarios for NAV. So these are executing, common, well, in this case, order processor scenarios, opening different pages, executing some actions. And we've, used these in the NAV team and seen how they simulate very well real user activity through the client. What it looks like, let's find an example here. There it is. Yeah, so this is just an example of the sort of code that's being written, and it's like saying, I create a session on the server, and then from that I'm opening a page, I'm executing the new action, I'm entering some data, validating the data, putting some, adding some lines to the order, and then pressing post. This is just to show you that it's not that complicated, but once you've got a framework to build on, and the framework is just basically the web services of the NAV web client. So you can call these interactions on these web services. So it actually makes it pretty easy. So once you've defined those, and then you can configure them to run in Visual Studio. So what I've done there is just set that up, and it just says basically run these tests in Visual Studio. Then I can, in this case, just kick it off now, and all things going well, we'll be able to see that load on our server when we start looking at the events and monitoring those events. So just to show you, I'll just show you from the previous, while we're looking here. If I can find my mouse again. Yeah. There it is. So that's from a previous run. So, at the end of the run, it's showing you, how long the certain tests took, and giving you a summary of all the events. And you can use these to define these thresholds and sort of benchmarks. And you can even define them in the test, so you can say, when the test runs, tell me if this particular action ever exceeds a certain amount. I mean, this is really fantastic tooling for anyone who wants to do, so it'll actually report. In this case, the threshold violations aren't actually, these were actually looking at, machine performance counters. In this case, because it was running on my machine, it's telling me, hey, you were running these tests locally, so they're hitting your machine really hard. It's not telling me anything about NAV. So I'll put that away now. We'll go back to the slides. So yeah, so that's just a bit about Visual Studio. I hope, has anyone ever tried using it to test NAV, using Visual Studio Load Test? No. Okay. So it probably looks like people would like probably a lot more information about that. Yes? Okay. That was just an introduction. Just saying it's possible. I guess we'll just say look out for more. So now we're going to talk about the performance counters in NAV and what they mean.
Yeah, correct. So now we're going to talk about NAV perf counters, and such as the test is currently running, we will start with a demo on which we are going to show how to actually monitor perf counters and how to collect the data sets with the perf counters.
There it is.
Yeah. So this is the Azure machine where the tests are executed. And if you want to collect the perf counters, what you do is you start a perf monitor and go to Performance Monitor and click Add button. So whenever you install an NAV install perf counter category. So let's find it here. So here it is. So it's called Microsoft Dynamics NAV. And NAV creates a separate perf counter instance for each NAV service running on the machine. So now we have only one service, so we have only one instance created. So let's add all the perf counters. Click OK. And here they are. Just very soon we are going to describe them, what they mean, and how to interpret them. For now, let's look what can you do here. Just small tricks. For example, if you're interested in some perf counter value, you can select this tool, highlight tool, and select the perf counter and see how its value was changing. As well, the perfmon has different views. That was the line view. This is the histogram view. It's very live, looks cool. And the kind of the most informative one is the report view, where you can see the actual values of NAV performance counters. So currently we see actually that the server is under load. Some operations are executed, and you can guess it from the changes to the primary key cache total request or results at cache total request counter increase. As well, you can see that some of the there are kind of two groups of counters. One group shows the absolute value, the other one is relative values. We will come back to them after a short introduction to a caching, because many of these counters are cache related. So another demo which I want to make for you is how to create a data collector set. So you do it as well in a perf monitor. You go to data collectors, user defined, click new data collector, then you choose create from template, next, and then you choose browse. And whenever you install NAV, you get a data collector set in the service folder. So this data collector set contains all the Navision counters and as well some system performance counters, which we think are interesting in the case if you want to monitor performance. Let's add it. So for example, it contains performance counter, .NET perf counters related to the garbage collector, IIS, web service, etc. Okay, now it's got created. Now to start the collection, you select it, basically, and click run. Then you wait until your perf problem is reproduced, and then after that you go back and stop perf collection. Then you navigate to the folder where the perf log is saved. It's saved in a perf logs. That was it. And by double clicking, you get a view which contains a lot of different perf counters. We can just browse through them briefly. So you can see here the group it's Navision perf counters. If you keep browsing further, you can see that there is some IIS related perf counters, SQL Server, and etc. And this view shows you the trends. Okay.
So if you, just to show one of them that actually does something, if you show the average server response time, just because we're running this perf test now.
Let's find it.
So you can the top average server operation. No, you just went past it.
Average server. I think this one, right?
Yeah.
You see.
So if you
there was a spike in the.
So there's showing that there was a big thing, and there's quite a variation in this because that performance test is actually doing a number of different operations. So a lot of it's just opening pages; they're pretty fast. Every now and then it runs a report, and that's the spike you can actually see at the end there, where it's running a detailed trial balance report or something like that.
Okay, so let's we will give you a short introduction to the cache, and then. Yeah, and then describe the perf counters. So the record API, CL record API have a set of methods which you can use to retrieve different type of result sets. And depending on the type of the result set, it is saved in different cache. So as you can see here, for example, the get call is saved in a primary key cache. All the find calls and count is empty saved in the result set cache. Count and these empty calls have some special place in the results set cache, but still they are there. And as well, we have a calc field cache. Yeah, so here I want to as well mention the autocalc fields, and the reason for that is because they are actually used a lot because they are set automatically by the client, and whenever the autocalc field is set on the record's result set calculates all the selected autocalc fields, and it calculates it in a single SQL query, but that result set is not cached. except of the case if you do a get call. In the case of the get call, it still calculates all the autocalc fields, but for each individual calc field, server issues individual SQL query, which is get cached. So important thing to remember that they are set automatically by the NAV client server-side runtime, and they are set to all visible flow fields which you see on the page. And they are persisted for the page triggers. Then just a bit about the query. So queries are as well not cached, and they're used. You should use them in the case if you want to replace the nested loop with a single join and don't issue multiple results. Okay, so that was a short introduction to the cache. Now we can describe the perf counters and what they mean. So we have a set of performance counters related to the cache, and they go in the pairs. So one perf counter shows the total number of cache requests of a given type issued, and the next one is the cache hit ratio. That means how often did we retrieve the item from the cache and did not go to a SQL server. So we have one for the primary key, one for result set, and one for calculated fields. So for example, if you monitor an NAV and you look at the perf counters and see that result set hit ratio is very low, that can indicate an issue in your application logic. For example, you are setting filters to primary key, or you are using select latest version, or you simply invalidating the result set by modifying the data in the table too often. Okay, so the other perf counters we have here in the slide is the counter which shows you the total number of rows in all the temporary tables. The reason why we have it is because by adding a lot of records in the temporary table, you can consume basically the whole memory, which you have, all the memory which you have on the server, and by monitoring that counter, you can indicate whether the memory consumption was caused by the by the usage of the temp table, so by some another issue. So maybe we can now switch back and look at the perf counters we have here. Yeah. So, for example, you can see on this slide that the primary key cache hit ratio is pretty good. So whenever you do a get call, you're almost certain gonna retrieve the item from the cache, which kind of suggests that if there is a way to get to use the get instead of find, then you should do it. For other type of cache requests, the cache hit ratio is as well pretty high. For example, you can see that result set cache hit ratio is 79. So it's pretty high, and the reason why it's low because we do whenever we do a write operation, the result set is invalidated. Yeah. Let's go back to perf counters and yeah. So here is a short summary for the caching. So there are not that many ways you can impact the cache behavior, but there are a few custom config file settings which you can change to impact the way the cache behaves. The first one is the data cache size. The default value is 9. 9 approximately means 500 megabytes. So that means that about 500 megabytes of result sets are going to be cached by the server. It's 9. It's abstract units. The reason why it's abstract units, and we don't document what exactly it means because we want to reserve the right for ourselves to change it in the future. But 9 actually means 2 in the power of 9. So if you, for example, have a server with a lot of RAM, you can increase it to 10, and that would mean that the server will cache up to 1 gigabyte of the result set. And of course, you can do vice versa. If you don't have enough memory, you can reduce it. The cache is, if you have multiple NSTs, then the cache is synchronized between them, and they and you can change the cache synchronization interval. By default, it's set to 30 seconds. That means that every minute you are guaranteed to retrieve the latest value. And you can bypass the cache, kind of bypass the cache by calling select latest version. That, if you call that function, it guarantees you that the result set which you retrieve will be cached no later than you call this function. Okay, now we go to a different set of perf counters. It's active session. It's session-related and client-related counters. Active sessions counter shows the number of active sessions. Server operation per second shows the number of server operation issued by the client to a server. Basically, each request its individual server operation. Yeah. Then the other one is average server operation time in milliseconds. It's clear what it means. And it's very important to monitor. Basically, whenever you have some noisy neighbor or high load on the server, typically this is the counter which spikes. When we have a set of SQL-related perf counters, which shows you the number of open tenant, number of open connection, heartbeat, and query reposition rate, and some other one related to a SQL query and command and connection caching. Okay, that's it for the perf counters.
Okay, so the next thing is if you want to monitor these performance counters remotely, and this is what we've set up here because we've got our server running in Azure, and I mean this problem of monitoring Azure machines came up pretty much as soon as people started deploying their existing applications to Azure, because suddenly things like connecting a performance counter remotely and all that became a bit more complicated. So the good news is that the Azure teams and the Visual Studio teams have been working on this problem. In fact, I think they've been working two separate teams on the same problem, but now it's all coming together in this tool that's called Application Insights, which integrates into Visual Studio and lets you instrument any application, but it also allows you to sort of monitor existing applications, in this case NAV. So it's actually quite simple to set up. You go into their portal and you create an application. You download this config file. You can customize it by just adding I want to collect NAV performance counters. It's just XML sort of thing, so you have to go in and edit it. I won't sort of go through all this now, it's pretty boring to watch. But then you upload it, put it in the web client folder, and then you install this agent on the machine, which is like that you download as well, so it's all just coming straight from the portal. And then you go into the App Insights portal, and you've got this nice dashboard. I've just taken pieces of it here, but it's measuring the availability of the thing, so it's actually doing like a response. Like it's pinging the endpoint that you define. I typically use the login page for the web client because you don't need any authentication just to hit the login page. So it's actually, you can configure it to send requests to that for you from actually all around the world, and you can measure the latency from different data centers in the world. That's really easy synthetic monitoring from remote locations. This stuff was pretty hard to set up your own before, or you could pay other people to do it. Now, if you've basically got an MSDN subscription, you can do it for no problem at all. You can monitor exceptions there as well, looking good at the moment. At this point in time, at least there was 0. And you can you monitor metrics, and you can see here we're actually looking at the NAV metrics. So it's not just the standard Windows metrics, but we're actually collecting stuff from NAV. And the last graph there is showing the response times from the various data centers. And this is the other cool thing. You can go in and set up an alert. So you can say, I want to know if, in this case, this average server operation time ever goes over 25 for a 5-minute period. So, if the average is exceeding, so it means, something's really slowing down the average response time. And then you can get it to send emails to you, which is, pretty nice. It doesn't spam you too much because it sends you one when the counter goes over the threshold, and then it tells you that the situation's happened, and then it'll send you another one if things go back to normal. But if you wanted to monitor a server and you don't want to be sitting there looking at it all the time, it's a nice way of monitoring. So this is you get a mail sort of just telling you this is what's happened, and it tells, hey, there's something unusual going on the server, it's time to go and have a look at it. So this is all pretty easy to set up. Oh, and I think just before we jump to that, I'll just, yep, we're over here again. I'll just show you just, what it looks like here. Yeah, so this is actually the portal here. And I've set up this dashboard and defined what things I wanted to show on it. You can see here, you can just go in and define alerts. And yeah, it's showing that it actually has gone critical. So we've loaded the server over that 25 millisecond limit for the purposes of seeing that alerts will happen. So if my phone was connected up right now, I'd be able to show you those little alert messages ticking in. I don't think it is because I've gone into flight mode. But believe me, they do work. There's and that's what we expect when we're running sort of this high load of these tests. Setting up the application is just going in. It's got like a bit of a wizard thing that asks you about it, and once you've got that running, you can go in here and you can actually go in. For example, once it's configured here, you can see we've got all the NAV counters being shown here in the alerts. So this is really what's happening is this agent is sitting on your VM, and it doesn't have to be in Azure, it just could be anywhere that's accessible, and it's publishing that data to a big data store that's in Azure. And this is the beauty of it, because when you start talking about all these performance counters and events, there's a lot of data involved here. And they're sort of doing that for you, storing all that data and presenting it to you in a nice portal here. And like I say, you can go in here and configure alerts. So allows you to define, what particular metric and when and how many, when it should be sending an alert and who it should send it to. So that's a quick. Is that how I get back here? You have to help me, Dmytro. Yeah, there I am. So that takes us to the next part of the whole presentation here, which is the application profiler. What's it all about? It's a tool we've put on CodePlex. It's basically built a monitor for NAV events, and it allows you to see, how long certain server operations take. So to get it, you just go to this CodePlex site. We'll put the link in here, and it'll be sent out in the presentation. You can either download the binaries, or you can go in and just get the source code, which is all there, and build your own tools. And I know someone here, I don't know if he's here, he's already forked this onto GitHub. So there's a person, what was his name? Sebastian, was it, I think? No, he's not here. Anyway, someone has. And I don't know if other people, would be interested in that project and doing it in that way, so they can contribute here. But we're welcome for people to contribute to the project here on CodePlex. So what it does, it collects all the events and then sort of creates a hierarchical view. It aggregates the events. The events typically, have some sort of a duration, and so you can see what events happened, what sub-events happened, which is a good way of sort of drilling into it. So you start off with like some sort of high-level session open, then you have a various client-server calls, which get broken down into AL statements, which result in SQL calls, and you can see how this happens. And likewise, you can also see the platform calls that are happening independently of the user actions. So let's just now try and see how you set this up. Does it work? Yep. So to begin with, if you go to the portal, you will download the product there. It's a zip file, and it just contains basically these things. So there's a DLL, two DLLs, and some pages, which for just collecting and displaying the data. So this DLL, the profiler, that contains a whole bunch of code for consuming the events and creating like an aggregated view of the events, which we then just read into an NAV table for display purposes. So setting it up just is like any add-in. You have to copy it to the server add-in and the client and the development environment add-in folders, so you can compile it. And once you compile it, and it'll run. Sometimes one of the problems people have had with this is when they've downloaded it, the files are marked as downloaded from the internet, so it won't load them, the assemblies. And there's just a flag you have to clear if that happens. That seems to catch people out. We've made a nice video showing how to do this, so I'll let you look at that. So once you run the profiler, you just run the page, and you can see here it was running a previous session that it's collected data from. If I start now, and then I go in here to a web client. Oh, I have to log on again. Wow, I even got that password right first go. Amazing. Yeah, so I'll just, for example, just go in and look at the items list here. And that should be enough to create some activity we can see. So now I'll go back to the profiler and stop it. And now it's just doing that aggregation of all the data that's been collected. So you can see at this time there were actually a few sessions running, but not as many. I think my performance test has actually stopped running now, so it was only running for 15 minutes, which probably tells us we have to speed up. Yep. So I can start that off again. And you can see here, well, what was the most expensive operation during this time? It was user 11, which was me. Opening a session on the web client. This is basically the cost of opening a session there. That was probably not me then. It was this one here, user 11. There was two user 11. Yeah. In this case, it's showing the different actions. So it's showing what's happening in the code unit, what calls that makes into, and then you can drill further down into it until, in this case, none of these things are taking a lot, but to see where there's SQL calls. Yeah, there's a SQL call here. So you can see how the breakdown from the call in from the client to the server. Yeah?
Just one comment. If you see the SQL statement under the record .get and .find, that means that was not a cache hit and it went to a SQL server to retrieve the data. So this is how you can identify if your record method call hit the cache or not.
So another thing you can do is you can pick up an existing file here. So if you've decided to collect a file from a previous session and you want to analyze it, you can go in, open up this collector file, and it'll process an existing collector file. You can see in this particular session, I think I actually had another one here I would like to look at. This one. Okay, so this was interesting because I was thinking, okay, why, there was an expensive operation here, why did it's taken, almost 2 seconds here, something. So you can also set filters and things like that here if you want to say, okay, what is the, if I'm interested in, so I want to see anything where the duration is, say, greater than 100, so I'm not interested in all the small events, and it helps you sort of narrow down to the event where the problem happened. And this one, it's this get system indicator, strangely enough. And I think this was actually when I know this was when I was starting the system up, so it was a sort of a cold SQL system. So that initial call to get system indicator, which seems like quite a trivial thing, involves doing some queries on the object table per company, which actually take quite a long time. So you can actually see that select statement there taking almost 1.5 seconds. So this is it's a good way at sort of looking at the whole picture of what happened and then drilling into what the operation that took the most time was. And then from that you can get to the SQL, and then you can maybe go over into SQL Profiler and have a bit more information about what was that statement actually doing. So that's the the features. There's also feature here because as you can see, as we know, SQL statements are pretty big, so you can click up here and it'll just show you the text of that particular SQL statement if you're interested to see what it was, and you can then go and maybe run that in SQL Server to see. You can also save the traces to an archive if you want to use them for comparison purposes. If you want to try making some changes and seeing before and after, then you can do a comparison there. I think we have some archives already. Oh. Nope, we don't. Oh, it's trying to open them. Yeah, okay. So yeah, there's a bunch of sessions that have been opened here, and you can also, if you take a session here, you can actually get it to calculate the ratio of the operation. So it'll show you quickly, which particular operation. Instead of looking at all the timings, it'll say which particular operation had taken the most of the time on in this hierarchy. So there's, all these features are there to be extended and added, and we're sort of hoping by putting it out on Codeplex there that we'll get input from other people about how it can be improved or what other things you would like to do with it. I hope that's... So if I switch back. Yeah. So yeah, as we saw, you can just profile a single session by filtering, or you can actually tell it to not even bother collecting data from other sessions. You can profile multiple sessions, and you can also analyze existing traces with the tool. So what's this all based on? So it's based on these events which we've been talking about. So you can now monitor these events from from any tool that can consume them, and you can use them to troubleshoot problems. And as I said, it's based on the ETW subsystem, which is part of Windows. So why do we want these events? Okay, now probably a chance for another T-shirt. Who's ever tried debugging a multi-user scenario on a production server? Okay. I don't know who I saw first. I think I caught your eye first. Yeah. Was it easy? It was easy. Easier in the new situation, yeah. Oh, with the new debugger. But nevertheless, the problem with debugging is that you get the what is it? Now I'm forgetting the word. Is it? It's a Heisenbug. Is that the word? Because the observer affects the actual environment it's trying to observe, and that's the case of the debugger. It's going to have an impact on performance. So trace events allow you to get the full trace of everything that went on in multiple sessions, seeing who was doing what and when, but without having the sort of the observer effect of affecting performance. And also because these events are happening very fast. There's a lot of stuff going on the server. It's never the same when you're actually stepping through the code. By debugging, you'll be disrupting us. Here, you're just letting things run their normal course. And also, a lot of things don't really happen unless there's a load on the system. Like, you need people to be having simultaneous action sometimes to be able to see, the problems. And again, the traces will show you what was happening at that time. There's, performance issues as well. It's very hard to, isolate them by sort of manually testing the system. It's much easier if you can run real workloads and then collect the events afterwards and see the timings for those events. So there's lots of reasons for using events, and that's why we added them to the NAV server. Of course, the other problem as well is that you can collect really vast amount of data today and parse it with these tools. So you can have these on for a long time. If you know that something's happening at some times of the day, but you don't know exactly when, it is possible to collect data for long periods of time. It has very little sort of impact on the system. I have to go back now. So just quickly, about these event traces is that you can, as well as, it's not just NAV that's producing them. Other tools can be producing. So you can actually be sort of collecting from multiple sources on the system and then correlating that information. And that might be really interesting in like if you've got some sort of end-to-end problem that you can't find out what's going on between the WCF calls and the SQL Server. But it might also be some integration scenario where you know that you're integrating with other systems and you want to see what they're doing. The event trace data is also the way it's working. It's got a timestamp, so you can fire really hundreds of thousands of these events a second. It's and each of them has a very accurate timestamp on it. And the cost is very low because it's being done at the kernel level. They're being buffered before they get written to disk, so it's sort of asynchronous from the perspective of the application. So it's very efficient in that way to collect a lot of data. And this is just an overview of how it works. So you've got some sort of provider. In this case, NAV Server is a provider. There could be others. You have a controller, which you sort of configure the session, like to collect the events. And then that's inside the session. It's what's buffering the events. And then they'll be consumed by a consumer. That might be just here writing out to a file, or it could be a real-time consumer. And that's what the profiler was doing. We set it up and we said, start listening, well, to yourself. In this case, NAV. So one session in NAV is listening to another session. So that's just to understand the architecture behind it. What events are we providing? Well, everything that normally would go in the event log is actually an event now. In fact, all events are created at this level. So they're all fired off as an ETW event, and then some of them, based on the type and the severity, are then just published to the event log. So that's also happening in that asynchronous way. The SQL events, whenever we open connections, begin transactions, execute some command, and read from a result set. Service operations, opening and closing the session, and then running the report is there because we consider that like a sort of a special type of event. It's usually quite a heavy processor event. A lot of the other events in terms of client interaction are really, because they happen over a much longer time, like running a page involves callbacks and things like that, so we don't trace that as an individual event of opening a page. But running report is typically a very data-intensive operation. And finally, we trace every AL function. So all the actions and things you execute on page become, some trigger gets executed, then you see the action on the AL, the resulting AL function call in the trace. If we didn't mention that already, there's a server parameter to configure that the server will trace all AL functions. So it's not on by default. Because it's not necessary by default. So it's only when you're interested in diagnosing you need to enable that configuration. So what you can do with these events is that what enables this whole performance profiling thing is that a lot of these events come in pairs. They come in a start event and a stop event, like start execute a function, stop execute a function, start open a session, stop opening a session. So just for the period of the execution, you'll have two events. And by looking at those two events, you can work out the duration. And most of the tools actually do that for you. So they show you in the tool, like we did with the profiler. You could see the duration for each event. Just a quick demo now of how you go about collecting events. So it's very similar to collecting performance counters, actually. In the similar way, you go in here and say, I want to create a new data collector set. In this case, we'll just do it manually. You say event trace data, and then you can see here we appear the event provider. So, you can collect all events, or you can actually do filtering here. We'll talk about that a little bit later about what possibilities there are to filter on the type of the events. But likewise, you could also collect, multiple providers here. So once you've done that and you've created an event data collector set here, I've created one earlier, then you can start that up. And I should have really kept my perf test running, so it was doing the work for me. Like I said, I was going to make life easy for myself. But I'm just going to here go and look at a list of customers, hopefully, in this client. Yep. And go back to the how many perf counters do I have open here? Oh, it's right over here. There it is. Yeah, lots of perf monitors open. So then I can stop collecting, and it's going to dump this file here. So let's just have a look at what does that file actually look like. So we've got a tool here called it's called Perfview, and when you configure the event collector, you just give it a path and then a sort of a file name thing. So you can see this is the latest one I just collected here, and it's got an ETL file. So it's dumped it out to a file, and you drill into that, and you can see all the events that happened during that little session when we're recording. So what you can do here, it's quite a powerful tool, so you can sort of look at all the events that happen, and this gives you an idea of what these events look like. So as you see, it's very verbose information, but you can see the durations here between the start and stop events. So it knows from every stop event it can work out the duration. So the thing is that all this sort of event collection, as opposed to normal just logging out text, it's structured information that the parsers can read. So they can interrogate the payload and say what attributes does it have, and then in this case a generic tool like this can understand the NAV events. You can also just go in if you're interested in a particular event. The open connection start stop. You can just look at the particular event and say how long did it take? Well, 4 milliseconds to open the connection there. So you can get a drill down, and you can also search and filter for specific events. If you're looking for a particular problem in that, you can search on the text of the event and set filters. And then you can also, there's a, if you're looking at the, so if you're looking at this thing, you get this little histogram view here. So if you're looking, there were a lot of events, what are the interesting ones? You can actually drill in and say, okay, this was the time I'm interested in, because they could see a lot of things were happening here. And then you can set the range filter, and it automatically picks up the timestamps of those events, and then you can sort of drill down into the events that you thought were interesting. So there's a lot of stuff. It's a very powerful tool, but it's also obviously a very generic and very flexible tool. So that's the process of using Performance Monitor to collect it and then viewing it in Perfview. And then we can see, that's what it looks like. So, like I said before, if we're interested in only certain types of events, we've got keywords defined. It's all listed in the MSDN documentation, so you can go in there and actually, configure it to only select certain events. And that's probably what you want to do if you want to be collecting data over a longer period of time, because you're going to be dealing with huge amount of data here. So you probably say, okay, we don't need all the data. We only need specific events. We want to see when they happen. If you've got an intermittent problem which no one's been able to track down, this is the sort of tool you would use for that. So now Dmytro is going to show you our noisy neighbor, and I'll.
Thanks. So so it might sound a bit complicated that there are a lot of events, not clear how to collect them, how to aggregate them, and how to analyze all that data. But we want to actually show you that it's pretty easy to.
Oh, sorry, you there, I'm here, yeah.
But we want to show you that it's actually pretty easy to build a tool which you can use to collect events and get some sense out of those events. What we've done for you is we've built a tool which can be used to identify noisy neighbor. It's part of this application profiler project, and it is checked in, and the source code you can find here. Okay, let's see first what does it do. So here I have Navision running, Yes, so I'm starting the 2. And what it should show is the currently active sessions on the server. So if I have an NAV, so such as I'm not doing up here, so there was some operation already, that's why the session appeared here. So if I start doing something here, I will, for example, just execute any operations on the server. You see these bars start moving, start increasing. What that tool shows is the how many percents of the time during the last sample interval the session had spent on a server. So for example, if you have multiple sessions connected to the server, and some of them is running something like an endless loop or some heavy operation and it's never exits, that tool will show it in as a spike. So let's demonstrate that. So here we have the client running. Now I will start the test code unit. Well, it's not a test code unit, but code unit which with a test code which creates several sessions. And let's see what we will get in the tool.
And I'm running my perf test again, so
okay.
we'll see lots of activity.
So basically, I've started the evil code unit, which, as we can see on this tool, which created 2 extra sessions, and they are heavily loaded in the server. So basically, each of them spends about 100% of the server time. So this is what it is. So it's if you need it, you can download it from the complex, and it's easy to install it. It's just basically a copy paste and run. So if we will go and stop all sessions, then we will see how these 2 bars disappeared. So as soon as the perf test will kick in, we will. Sorry, that's my local.
You're running locally.
Yeah, I can. Well, I can run that. Yeah, I'm running locally, but I can run it remotely as well. So now let's see. Yeah. So this is the perf test running on the server, and we see multiple sessions and basically how much time they spend on the server. We can see that none of them are very heavy. We will see huge spikes whenever the heavy reports comes in. Yeah. Okay. And such as this session is 400 level, we want to show you yet again the source code. And we want to prove you that it's easy to build such tools, and it's easy to consume events and use them. So this is actually the source code for the tool, which you just see. So it's a simple WinForm application with a single control, and it's about 100 lines of code, or even less. So what it does actually, it creates, instantiates the profiler, which start listening to the events happening on the server, and this line basically says to the profiler, please start listening. And then it runs a loop, and in that loop, it waits for some sample interval for some hard-coded duration, and then it suspends the profiler, which is running in a separate thread. So the fact that we sleep in this thread does not actually stop the event collection. So it suspends the profiler, then gets all events from the profiler, and it basically says, I'm interested only in the root level events. I'm not interested in the details. I just want to know how much time the individual session has spent on the server. It takes those events, puts it into array, and whenever we update the chart control, we just grab the data and bind it to the X and Y axis. So it's pretty simple, and and from one side or from another side it can be used, and it can give you some insight on what is going on the server. Let's have a look what happened here so far. Yeah, let's keep well, we can see the tests keep running. We can remove all the inactive session and see what else.
And what you can see here is when you run like an example like that little nasty loop code unit, it'll have an effect on all the other sessions. So you can see how
yeah,
it'll
we can
push
we can do it. By the
I don't know if you've got that running. Oh yeah, start. Yeah. So
okay, here we have.
You can actually see that the sort of the duration of all the other operations will start to be affected by the fact that there's this one blocking operation. So you can, and then you can sort of identify very clearly when it happens what the blocking operation. Oh, it stopped. And now, yeah. So you can see this is the user who's blocking, and it's affecting the duration of all the other users.
Yeah. So
well.
all other durations became bigger.
Yeah. And then my mobile phone's going to start getting a whole bunch of alerts now. Things are taking too long on the server.
Yeah. Yep. Okay. So what was? Did you like the tool?
Well done. I think I have to put this back in. Is it working again?
Just click next. Just
yeah.
Yeah.
Next demo.
So one way of profiling the server is to use the NAV profiler. That one you have to install, you have to download and install. There is another way, it's a bit more lighter, it gives you less information, but you don't have to install anything, basically. It is part of the product. It's SQL tracing, which you can enable on the server. So let's cover that one. Yep, so we're back to our environment, and I won't go in too much details about the SQL tracing. We have a link in the end of our presentation to this blog post, which describes how to set it up and how to use it, and as well it has the sample SQL scripts, which shows you how to aggregate the data. But I will show you the first demo. Yep. So here we have a SQL profiler running. So let's, and I should have at least, okay, let me try. So to start the SQL tracing, you go to a sessions window.
It's down, it's in the background.
Oh, it's
yeah,
here.
It was
here.
Yeah, you've got it. Oh, okay, it was open.
Okay, let's try again.
Yeah, it was already open and lost its session when we shut down.
Yeah. And you can see that it's already started. So, but the thing is that you can start the SQL tracing for all sessions or for individual ones you want to trace. So currently we have only one session. And the tracing is started. So let's try to profile the sales order creation. So we click here, sales order, yeah, that's enough. Let's stop here. So let's see what we've got here. So here is our SQL trace. No, thanks. That's a good example. So here we see the SQL command which contains only comment. And this is what the SQL tracing is doing. It starts issuing the comments together with the SQL statement. And right after that comment, you can see the actual SQL statements. And that actually indicates that these SQL statements were caused, these two were caused by modify. So whenever we did number series dot modify, we've got these two statements. If we go further, we can see here find last and the corresponding SQL statement. And actually it's pretty big. Yeah, order by. It could be, I just wanted to figure out does it have any calc fields or not. Anyway, so if we will look further, we can see that there are comments with no IO call stack. That means that SQL statement which is below that comment was issued by the platform, basically, but by that block on the nav diagram, which was on the very top. It's client-server runtime. Yeah. Okay. And as soon as you collected this trace, you can save it into a table like that. I have already done that. And then if you go to a SQL Management Studio, you can execute a bunch of queries which will do some type of aggregation of the data you have saved. So this is already prepared, so I will simply go through some of them. So for example, first query, the result of the first query contains the mapping SQL statements to the AL code mapping. So here we have twice modify call, which we just saw in the SQL trace. That means that the modify call has caused two different SQL queries. And for find last, we have one. And for this one, we have another one insert. Okay, that's first result. And the second thing which you can get is actually you can get the sum of duration and average duration and the other statistics per call stack, per AL call stack. And the third example was account. So you can simply see account how many times the individual AL statement was executed. Yep, that's it for me.
Next. Probably got the wrong thing plugged in.
Yeah, that was it.
Okay, so this is so you're probably thinking, okay, we've now shown you 10 different ways to do the same thing, and you're right, there are. That's the great thing about it. There's a lot of different tools which you can use, and it's a matter of, choosing the right tool for the situation. Now, I mean, the scenario there, Dmytro showed was, more sort of an investigation about a particular operation and seeing what SQL statements were executed. Another possibility is you've got a situation is you want to see overall what are the operations which are taking the most time. And if you're looking at optimizing your indexes, you might want information like, okay, so what indexes are not being used for reading? Like we've got indexes on tables, we've defined keys on tables that have generated indexes, but they're not actually being used by anyone for reading. And likewise, what tables need indexes? And all this information can actually be found in SQL Server. They've created views for all this information. Now, the views are, there's quite a lot of these different views. So I'm just going to show a demo of some sort of basic queries we've created on top of these views that answer those three questions. So if I go to SQL Server now, wrong machine. Yeah, I've got to get back on here. Close that guy and that guy. Okay, so the first one was, and so I've got a link to the help for this, but there's a documentation on MSDN about these views, tells you what the fields mean and everything. I'm not going to go into the detail of all the fields. What we've done here is, and we've put this code in the source code for the app profiler. So if you go and download that from the app profiler, you can get these queries. They just basically create simplified views on top of these dynamic management views. So the actual dynamic management view here is this one, which is query execution statistics. So by executing that here, and here I'm just saying, okay, show me all the statements ordered by the averaged elapsed time, which is in this case in microseconds, and where it's been executed more than 10 times. Take a little. This query itself is pretty expensive as well. But what we can see there is, an overview here at the bottom of, since we restarted the server, which was sometime this morning, of all the operations we've done, what are the most expensive ones. You can see reading code, reading metadata. These ones come up pretty highly. I mean, that's a large part of the SQL's going on, particularly in the case where you've just started a server up, because it's caching a lot of the metadata at the start. But they've been, that reading in AL code, this is probably for every object that's been executed, it's had to for the first time, read in the code. But if you look around a little bit there's some insert statements here that, are perhaps a little bit more interesting. In this case, value entry table. So, we can say, okay, that's taking an average of, it's been executed a lot. And you can see as well, GL entry as well. So the inserts to these two tables, this is probably no big surprise to you all, but they're some of the most expensive operations that's happening, and there are a lot of them happening. Normally, particularly you see the value entry there in this case, not so much the GL, because I'm not doing a lot of posting there. But if we look into this statement here, it's quite good because it can actually show you over here, if I can find the row. Yeah. It'll actually also cache the execution plan. In fact, all this data is being kept for any query that is in the cache. So as long as the query is in the cache, it'll keep that information. And obviously queries that are executed a lot will stay in the cache. And this is interesting because it shows you straight away exactly why is this insert taking a long time. And it's not because of the insert. I mean, that insert cost was 47% of the time. What's taking the rest of the time is updating all the related indexes. So that's interesting information. It's like, okay, do we need those indexes? Well, we've got another query that'll help us find that out. So if we go over here to another dynamic management view, and this is called, as you can see here, it's fairly obvious, index usage stats. We can just run this again. And now we were looking into, where was the execution plan here? So it was the value entry. So if we look down here, we can see that here we've got, and it's actually ordered by how often people have been reading, like seeks, scans, lookups, and as opposed to updates. So it's actually, the view we've created here is to show you which are the indexes which you're writing to all the time, but you're not really reading from. And as in this particular case, you can see there's a lot of them from value entry that just aren't being used. You're paying the cost every time you do an insert, but no one's using them. Now, it might be that in my particular scenario here, I haven't executed a report or some particular job that might use those indexes. So obviously you'd be wanting to run this over a longer period of time to make sure you've got the, the information about the total usage. But, in this case, for my very limited scenario, these indexes are a waste of time and probably should be turned off inside the Seaside Designer, not in SQL. Likewise, you can also run another query which is very easily named. This one is just called missing index groups and missing index details. So you have to do a few joins here, but again, we've created a nice little query here to do that for you. Oop, we have to run it again. And this one isn't necessarily telling us that there's a lot of stuff missing, but it's saying, there is it's telling us we need an index on our performance profiler. So that's what we've been running a lot. So I could see that we're doing a lot of queries on that as we're demonstrating it here to you. Now, actually, we don't want an index on that. So you don't believe everything this tells you to. But it might be, again, in a case where you've been doing a lot of queries of the system, it'll point out to you the ones that the NAV tables that really do need an index if that's the case. So yeah, that was just a quick overview of these views. Like I said, the link to the MS documentation tells you a lot of them, and we've saved these queries in our CodePlex project if you're interested in having a look at them. I think they make it myself, I think it's made it really easy for me to understand, and particularly the one about like finding out which queries have been executing most. We've used that in troubleshooting sometimes, and it surfaces up sometimes. You know, you see this query that's being executed all the time, and you say, why are we querying that all the time? And it's something that's not being cached that should be cached. So you get some ideas into where things are working, not. So there's links here in the presentation when you get it to these particular dynamic views which I've just shown you, and they're the names of the ones to look into. They're very useful stuff. So, well, it tells me here we've got 6 minutes left. And it's time to say, well, did we learn anything today? Yeah? Oh, good. That's nice to hear. So we learned about what performance information you can get out of NAV Server, about how you can monitor, all the different ways you can monitor, and there are really a lot of different ways, and what tools you can do to do performance analysis and diagnosis. Did that cover everything?
Yep.
Yeah. So I guess it's time to say, and there's some references here. This is in the slide deck, so I know you're going through, but a lot of this stuff we've got how-to videos, and there's descriptions of the features in MSDN. So now it's time for you to ask questions. Very fast.
In the beginning, you showed the Visual Studio for emulating the web client. Will you create other tests and then publish it as a template?
Well, I hope, yes, that will happen. The current situation is that in order to build these tests, you need a framework for calling in the UI actions. Now, you can build that yourself for the client UI web services. So you can go in and look at the web services and find out what can be called. But as there already exists some internal frameworks for doing that, I'm saying I would be encouraging the people, and I know there's some people who really want to do this, to release those frameworks to make it easier for people to do this. So right now you can do it, but it's a bit tricky. By releasing those frameworks, it'll be really easy. I would wait for those frameworks to release. I can only say, stay tuned. And I'll make it through the CodePlex project and everything. I'm hoping I can publish some templates and things based on those. Yeah.
Okay. What I want to know that in NAV Performance Profiler, you said that it will trace all the sessions. Suppose we are making a web service call from external application into NAV. Will it trace that as well, or just the NAV sessions?
Dmytro?
Yeah, it will trace that as well.
Web service call as well, yeah.
If it executes any IO code, it will be there.
It will get traced in that profile.
Yeah. So there's not a specific event for the web service calls, but you'll see the corresponding AL calls, and you'll see the session that's calling them.
But we can distinguish it.
Yeah, you'll be able to see by the session.
It shows the type here. If
it shows the type of the session. Yeah, it's just there won't be a sort of like showing the actual web service call, but it'll show the actual. Well, what did it actually execute?
Well,
you can't see it
anyway. It shows the open session, and you see here the type of the session.
You can't see it.
Oh, sorry, guys. Yeah, here it is. You can see the type of the session.
Yeah, but if it was a web service, you'd see web service.
Yeah, you will see web service.
Yeah, you can see that sometimes.
Can see web service instead of web client, yeah. And suppose we have SQL Server installed somewhere, yeah. It takes all the resources of that machine, isn't it? Doesn't matter. You have to restart the machine to bring it down. Suppose you have 32 gig of RAM. It takes all the resources, SQL Server.
So if you're running SQL Server on the same machine and it's taking,
all the resources of that machine.
Yeah, but you can actually limit that. You can limit SQL Server.
But it means we are limiting the queries, isn't it? We are limiting the sources for the SQL. Is there any optimization for that SQL performance?
Well, SQL will take all the memory it can. It's designed to do that. But what you can do is you can set maximum memory limit on SQL. Yeah. So the next session we'll talk about that. Actually, that's the focus. Very good point. Yeah, he'll discuss exactly that in the session. But a lot of people have asked us about this. We don't have any memory limit on NAV itself because we're using like the CLR, so it's managing the memory for us. But SQL, on the other hand, will, as you say, take up all the memory it can get. And if it can get the whole database into memory, then it will. So we have to be aware of that. Any other questions?
Is there a trick to, some special tool to find or debug a specific SOAP call? So if I say I have 100 SOAP calls per minute, and I know it's always one of 3 published code units or pages, and I want to debug one special event, is there some trick to get exactly that session?
You can filter on in here you can filter on the object IDs, and you can actually filter on the lines of code. So you can set quite clever filters also in the perf view tool on the data that you're trying to filter down to. So you could show, for example, show me all the
SQL
code unit 1.
Okay, code unit 1, fine.
Is that what you were saying? You were saying a specific SQL or a specific code?
Well,
yeah, but then you can use the debugger
Yes.
to attach to that session.
Oh.
Okay, yeah, that's true, but it's hard to hear your question there. Which version are you using for that? R2, because isn't the web session? I thought it was being
The question was
persistent.
how to debug a web session.
Yeah, because they're so
because they
intermittent.
come. I mean, because it's very short running. So how to attach to it?
Yeah, it's a good question, but yeah, you could. You could do it by this tracing way, and then filtering, so you would be actually collecting the data for all of them, but then you would be having to filter down by textual basis on what information which particular one you were looking for. We could talk about that afterwards, actually, if you want. Yeah, nice.
Maybe the last one?
Hi. Since the various clients are getting more and more important, do you think there's also a way to distinguish between web client or a tablet client? Because they're both from IIS.
No.
I can't remember if it actually shows tablet client as a separate client type, because they're both really coming through the web client.
I don't think there is a difference.
That's
you can distinguish them probably by the user ID, by the username.
Yeah, but I don't know actually if it's possible right now to distinguish whether it's seen as a separate client type. I don't know if we can no, I can't answer that one right now. I'm sure that someone from the client team would be able to. Yeah.
Maybe I could give you
one more up there. Yeah, good question. And there's one more T-shirt. Yeah.
last one.
Excuse me. I have a question in regard to a problem that I'm experiencing with the 2013 R2. I think when there is application externally through web service, manipulating data with a high occurrence of reading and writing, external application, somehow it destroys the cache of the middle tier and gives lags to the RTC constantly. To solve this problem, I had recommendations to separate middle tier and web service. Also, I had another recommendation to separate the executable for middle tier and web service. I want to know if you have any information about these solutions and the problem that I'm talking about.
Yeah, without knowing a bit more about it, but it's
We need to get a bit into details.
Yeah. Maybe we could catch up afterwards and find out a little bit more about it. Yeah, but it doesn't. What you first described there, which was one of the things we were talking about earlier, is that if those operations from the web service are, like you say, disabling the cache by invalidating the cache all the time, which affects the other clients, then maybe it's, what you need to, investigate is to, well, is it because everything's being updated constantly does it need to be updated by that web service? I guess you would have to look into the SQL to see why it's invalidating everything, if I understood your question correctly. So the profiling might help there to find out why that's the case. Yes? It's, well, possibly, but I know that I didn't personally do it. I know someone from the NAV team who investigated this hackathon and whether there was any advantages, but because we're already caching a lot of the data in memory, so the typical usage, as I understand, for the in-memory tables is you say, okay, this table isn't changing much. Let's keep it in memory, and the NAV server already does that. A lot of the data that persists is kept in the cache.
Yeah.
And on to speed there's possibilities there, but from what I understand, just from what I heard from this analysis, that he couldn't see any obvious gains from using that by trying it out.
I think we prototyped it.
Yeah, there wasn't any real quick, easy gains to win. I can't remember. He had some reasons why, like it was doing a lot of what was already being cached on the middle tier. So why go to SQL when even in a multi-tier scenario, like it's the cost of going to SQL would be more than the benefit of having it in memory in SQL. It's the hop that's really expensive. Yeah. I think we've just about run out of time now. It says bip bip to us. We've gone 4 minutes over. There was your T-shirt. Good question. Thank you very much.
Thank you.
If anyone's left.